Okay, hello, you're welcome to my channel. Now in this video, I want to evaluate the limit of this function as x tends to 0. Good. So one way we will start is by substitution. So as x tends to 0, okay, let's just see what happens when if x is equal to 0, that is, plug in 0 into the function, right, and see what we have. So by substituting 0, this should mean cosine of 0, all right? Cosine 0 is just 1. So we put down 1, and then minus 5 times 0 will give us 0, right? So we have the e raised to the power 0, which is just 1. Good. So again, we have 1 in the numerator. Cosine, well, 4 times 0 will be 0. So cosine 0 again is 1. And then minus e raised to the power of 0 is still 1. So we have a 0 over 0, which is an indeterminate form, okay? So this is indeterminate. We do not want this kind of result. Okay, so because of that, we're going to be using the L'Hopital's rule to evaluate the limit. And the L'Hopital's rule tells us that the limit of this function is the same thing as the limit as x tends to 0 of, you differentiate the numerator, okay, that is the derivative with respect to x of the numerator, which is cosine, okay, which is cosine of x minus e raised to the power of 5x, that is the numerator, and then we divide it with the derivative with respect to x of that denominator, which is cosine of 4x minus e raised to the power of 2x. Good. So that is from the L'Hopital's rule. Maybe I just indicate for you here, all right, just in short. Okay, so the L'Hopital's rule tells us when we have an indeterminate form, which is 0 over 0 or infinity over infinity, we can evaluate the limit by differentiating the numerator and then differentiating the denominator, okay? Here is not a quotient rule where you say the derivative of the denominator, all those things. Here you just differentiate the numerator, divide it with differentiate the denominator, okay? Good. And then substitute 0 again and see whether we will have a 0 over 0 situation. And if we have it again, you can still differentiate it one more time, okay? So you can differentiate as many times as you want. So we put this down as the limit as x tends to 0. So we now have to differentiate the numerator. So the derivative of cosine of x will give us negative sine x, all right? That is from the derivative of trigonometric functions. So we minus it with, well, the derivative of this natural exponential function, e raised to the power of 5x, okay? When we differentiate that, we will have to put down the e raised to the power of 5x, okay? That is the derivative of e raised to the power of something. It is e raised to the power of that thing times the derivative of the numerator of the power here, okay? So this power here is 5x. So the derivative of 5x will just give us 5. That is by the chain rule. You differentiate the whole function, keep it, and then you multiply it with the derivative of the power, okay? Since it is a function of x. Good. And then we say that divided by, well, the derivative with respect to x of cosine of 4x. Good. This is also another function of function. The derivative of cosine of something, okay, with respect to x will give us negative sine of that. And that is 4x. We are not done yet. We multiply it with the derivative of the inside. The derivative of 4x is just 4, okay? So maybe I can multiply this function with 4. So we'll have negative 4 times, okay? Good. And we are done with that. We put minus derivative of e to the power 2x. Good. So e to the power 2x, okay, it is a function of a function, okay, e to the power something. The derivative of that is just e raised to the power that thing, which is 2x. And then we multiply it with the derivative of the power. So the derivative of 2x will just give us 2. Good. Okay, and now here we have, since we have done differentiating, okay, maybe we can substitute 0 again into the numerator and denominator and see what we have. So when we plug in 0 in place of x, we'll have negative 0, okay, which is just 0, right? Then minus 0 in place of x here. Let me put this down. That is the function we are evaluating. Now 0 in place of x here, that will become 5 times 0, which is 0. E raised to the power 0, the answer there will be 1, right? So we have negative 5. because this is just 5 times 1. Then we divide it with, well, sine 0 will be 0. So 0 times negative 4, then we're just going to have 0. Then minus 2 times e raised to the power 2 times 0. So 2 times 0 here is just 0. So e raised to the power of 0 will be 1. So we have the minus 2. And then all in all, we're going to have 5 divided by 2 to be the limit of that function. Okay? So maybe here I would have just said that the result is cosine cancels cosine, because when we differentiate that, we have sine. Okay? Sine. So as x tends to 0, we have 0, 0. And again, we have 5 over 2, which is this exponent. But that doesn't always work for all functions, okay? So you have to do this and then get your result just by L'Hopital's rule. Okay. Okay, thanks for watching. Please subscribe to my channel.